And before we start talking about domain, let's first talk a little bit about something called function notation. And function notation, it's really nothing special. It's just a different way of looking at equations. So maybe in the past you've been used to just seeing things like y equals x squared. But that and f of x equals x squared are equivalent. The second way I wrote it there is just what function notation is. We're just replacing the y with an f of x. So we're saying this is a function defined by x. So this f stands for function, and that function is in terms of or is defined by x. And now people always ask, why do we use function notation? What's the point? Why would we use f of x instead of just y? Y seems a lot more simple. And the reason for this is, for y equals x squared, let's say I wanted to ask the question, if x equals 2, what is y? Now, that's fine. There's nothing wrong with that question. It is kind of a lot of writing, and the less writing, the better, in my opinion. So the nice thing about function notation, at least one of the nice things about function notation, instead of saying if x is equal to 2, what is y? I could instead just say find f of 2, and I'm done. I've asked the exact same question. It's significantly more concise. It's a lot more quick to write. It's a lot more quick to read. Those two things mean the same thing here. So if x equals 2, what is y? And find f of 2, those are also equivalent. So function notation is nothing special. You're just replacing y with f of x. Let's do an example to kind of get used to function notation a little bit. Let's say given f of x is equal to x plus 1 divided by x squared. Let's find, let's do a few things here. Let's do first things first. Let's find part A. Let's do f of 3. So you'll see some problems like this on the homework. I think there's 2 of them like this on there. So if you're given a function, in this case where you have x plus 1 over x squared, and I want us to find f of 3, all you need to do is replace every x you see with a 3. So in this case, we'll have 3 plus 1 over 3 squared. So I plugged in, instead of x plus 1, I have 3 plus 1. Instead of x squared, I have 3 squared. 3 plus 1 is 4. 3 squared is 9. Can't simplify that in any meaningful way, so I will leave it like that, 4/9. Let's do a few more parts here. Let's say part B. Let's find something a little bit different. Let's say f of e. Why would I want to find f of e? I don't know, but we're practicing function notation, so let's go ahead and do f of e. Our original function was x plus 1, so now we are going to have e plus 1. Divided by, originally was x squared, now we'll have e squared. Certainly can't do anything with that, so go ahead and box that. That's my final answer. So again, point being function notation, whatever you're being asked to plug in, f of e in that case, just plug it in for every x you see. Let's say part C, let's do f of t plus 6. So f of t plus 6, let's see here. So I need to plug that into x plus 1 for that numerator. So t plus 6 plus 1. So I replace the x with a t plus 6. Divided by, in the denominator, I had an x squared. Now I'm going to have a t plus 6 squared. And when I checked your homework, it asked you to expand this out. So t plus 6 plus 1 is t plus 7. Combining the 6 and the 1 there. T plus 6 squared, I'm going to FOIL that out. That'll give me a t squared plus 12t plus 36 there. And let's do one more, just to kind of drive home the point of this function notation stuff. Let's do f of panda. Again, just like part B, I don't know why I would ever want to plug panda into this function, but let's do f of panda. So f of panda, we're going to have, instead of x plus 1, we are going to have panda plus 1 divided by, instead of x squared, we'll have panda squared. I don't know how to simplify any of that, so I'm going to say I'm done. Pro life tip, don't try to square a panda. They do not like it.